This time what we want to do is find the sum of an arithmetic progression. So all the terms that we've got, we want to add them together and see what they sum to. Now the two formulas we use for this one, the first one uses the n, a and d again. It's very similar to the term formula. This time it's n on 2 outside of 2a plus n minus 1 times d. Be wary of the brackets, make sure you've got them in the correct spot, and make sure you're multiplying everything in the bracket by n on 2. If we have the last term in the series, depending on what we've been given in the problem, sometimes we can use the formula n on 2 outside of a plus l. So we can use the first term plus the last term in a bracket and then the n on 2 outside. But again, that's only if we get the last term of that series. So in the first question here, we have to find the sum of the first 25 terms. Now we could probably add them up, throw them in the calculator. It's not the easiest way to do it. If it was 125 terms, it will take a lot of time and we could make mistakes very easily. But what we need to do is identify our first term. We've got 6. Our common difference is 4. And we can see that doing the subtraction, we get 4 each time. We've got n is 25. And we're going to apply the formula. There's n on 2, and bracket 2 outside of multiplied by the a and the n minus 1 times the d, and put it in the calculator once we've done that, and we get 1350. In the next question, we've got our last term 494 as well as our first term a, but we don't know how many terms we have. We can find d because we've got more than terms in there, so 14 minus 9, 19 minus 14 is 5. So what we need to do is use our Tn formula, because we've got Tn, we've got a, we need to find n, and we've got d. So if we substitute those in, we end up with a nice equation with just n in there, which allows us to see that there's 98 terms in that series. So 494 is the 98th term in the series. So that means we're going to sum the first 98 terms in the series. We can use that second formula, which is n on 2 outside of a plus l. We put that in the calculator and we get 24,647. You could check using the first formula as well to see if that actually still works, because you've got a, you've got d, and you've got n is 98. Well, this time what we've got is the sum of the series. We need to again find the number of terms in the series, because we know that the first term is 6. Our common difference is going up by 2, so it's d is equal to 2. So we use Sn as 2064, and we substitute, we get an equation in terms of n. When we simplify this, I've multiplied the 2 by 2 on both sides, so 2064 becomes 4128. We've just got n outside of the simplification of the bracket, which is 2n plus 10. Expand the bracket, we get 2n squared plus 10n. Now we've got a quadratic. If we divide everything by 2, because it's common, and bring all the terms together, we get n squared plus 5n minus 2064. Now if we factorize that, we get 43 and 48 as the factors of 2064. We get n minus 43 and n plus 48. Now n is going to be 43 only, because we couldn't have the value of n here being minus 48. If it's minus 48, it can't be a term in the series. This is one of the situations where a quadratic equation is going to give us an answer that is not going to be valid for the problem. So n would be only equal to 43. In question 4 here, we want to know how many terms in the series. It gives us 378. So our series 53, 49, 45 means our common difference is minus 4. We've got the sum, we've got the first term. Again, we set up the equation of that sum of the series with 378. Again, we're going to try and make it simplified by multiplying by the 2 to get rid of the fraction, cleaning up our bracket to give us 110 minus 4n outside of n, and then we're going to have expansion, get all the terms together. We divide by 2 to make it a little bit easier. Not a nice one to try and factorize this time. So by the quadratic formula, you're going to get two solutions, 14 and 13.25. This time we're only going to take n is equal to 14, because n is equal to 13.25 will give us an integer, won't give us an integer. And remember, we have to have an integer if it's going to be the number of terms. It can't work.